Prime factorization. According to fundamental theorem of arithmetic, we know that n can be represented by this form. According to the commutative law of multiplications, we know that we can sort P1 to Pj into ascending order. In that case, P1 smaller than P2, smaller than P3, and smaller than Pj. In that case, we know that we can apply for child division to solve this problem. We use I to iteratively go through 2 to n. We will find P1 first. Then we decompose P1's exponent from x to 0. Then the remaining will be P2, P3, Pj. Then we will keep increasing I until we find P2. Then we decompose y to 0. And we will repeat the same process again and again until we decompose all the prime vectors. In this case, the time complexity will be omega log n. And if it is a prime number, then I will go through all the numbers between 2 and n. In this case, the time complexity is O of n. This is a code implementation of the child division method. Do we have a better solution other than O of n? The answer is yes. There's the theorem saying if an integer is a composite, then that composite has at most one prime factor that's larger than square root of n. I won't prove it here because it's easy to prove using contradiction rule. By using the theorem, we know that if we can sort all the prime factors here, it is easy to find out the rightmost one will be the one prime factor that's larger than square root of n, and the exponent must be 1. In that case, we only need to try all the numbers between 2 and square root of n to find most of the prime factors. And if the remaining part is larger than 1, then that would be the last prime factor we want to add to the result. In this case, we know that if it is a composite number, the omega n will be log n as before. And the worst case, if the prime number, we only need to check square root of n times to find all the prime factors. That is itself. This is the optimization part of code. You will see here we only go through square root of n times to get all the prime factors. And finally, we check the remaining part. If it's larger than 1, then it is the last prime factor.